Welcome to our presentation on carrier logistics and our fax transportation management solution. Carrier logistics has been providing leading-edge technology that powers asset-based LTL companies for over 50 years. In this fast-paced world, there are unique requirements that can only be met by software specifically designed for LTL and the last-mile industry. Fax is an enterprise solution that's used by carriers big and small, to enhance all aspects of your business. Fully automated from a pickup through to general ledger, fax provides the tactical tools for rating and invoicing, dispatch, customer service, line haul, cross-dock, interline, driver payments and management reporting. And of course, it's fully integrated to our back-office accounting suite and comprehensive online customer shipping tools. What you're looking at now is a terminal operations planning screen where we're planning tomorrow's deliveries out of the New York facility. We're going to use this screen to show you 3 different routing solutions within fax, all with different degrees of automation. Geographic routing with empirical optimization, manual routing with route level optimization, and full terminal optimization powered by robust AI. In this video we will show all 3 of these approaches. On the map view you can see the location of each stop. And if the stop already has a route assignment, you will see the color definition showing you how those stops are allocated to routes. In our example, as we specifically set up Brooklyn to route with our geographical empirical optimization, you can see that Lower Brooklyn is in green, the wharf area is in dark blue, and the routing for Northern Brooklyn is the pink color. The computer optimized the order of each one of these 3 routes and also managed special requirements and fleet capabilities. However, this was mostly a geographic decision where it looked up the geography in a predefined routing guide that you set as an operator, and then executed that routing guide without attempting to do a full terminal optimization. If you then want to make any adjustments to the routes, for example, if you wanted to move a stop from Northern Brooklyn to the wharf, or from the wharf into Northern Brooklyn, it's just a matter of selecting the stop, right-clicking and moving it to another route. Geographic empirical optimization is a very quick way to get your route set up quickly with an emphasis on geographic rules. However, in some cases, you may want to manually build routes without any geographic automation. Doing that is as simple as lassoing some stops, and then ensuring that they're being routed in the order that you want. Here we can see there are a number of stops in the western portion of the terminal. We're just going to group those stops with our lasso tool. And with just a few mouse clicks, they now become a route. Here, we can double check our service windows, or ETA, by looking at that route in detail, making sure there aren't going to be any conflicts. Again, you can toggle the order, you can move stops, plus undo any of these decisions. In addition to the 2 methods that we just demonstrated, the geographic-based routing and the graphical solution where you build routes by lassoing stops, there's also a full terminal optimization solution, which is extremely powerful, and uses the computing power of AI for optimized vehicle routing across the entire fleet. It looks at predictive traffic, travel time, time at stop, and all service and time commitments to automatically build routes for you, without you having to predefine zip or postal codes and without you having to use a lasso. To understand this, let's take a quick look at the building blocks of the option, which are how many trucks you have to work with, and the capabilities of each one of those trucks. On this screen, we can see what vehicles are available to us and we can see the attributes of each vehicle. Those attributes include capacity, how many pallets can it fit, how much weight can it handle, and does it have a lift gate? You build these attributes, so it's whatever is pertinent to your fleet. Here we have tractor trailers and straight trucks. It's assumed that the straight trucks all have lift gates, but only some of the tractor trailers do. That's all been set up in advance. If you add a vehicle, you go to this screen and add it. If one goes out of service, you go to the screen and take it out of service. From here, if we take a look at our stop list again, everything that we're seeing in the bottom half of the screen, well over 400 different stops, the computer is going to find and evaluate all of the unplanned deliveries and put them through the optimizer to determine the best way to service those stops with the available vehicles. All the time subject to constraints of vehicle capacity, service windows and vehicle capabilities. The optimization also honors truck road restrictions. Again, it's using predicted traffic patterns and the anticipated start time of each vehicle to create an efficient and logical route plan. So let's go ahead and tell the computer to process the optimization. By selecting our New York City terminal, we're telling the system to begin. It's not going to optimize those 3 routes in Brooklyn that we had built using the geographic rules, nor is it going to optimize the one that we lassoed because we're telling it to respect the ones that we've already pre-assigned. But everything that's left is going to get auto-routed by fax. One of the amazing things about this solution is how fast the auto-routing is, as it's actually going to return the optimized solution of over 400 stops in less than 2 minutes. As we're not going to make you wait, we're going to fast forward 2 minutes and show you the solution that the computer came up with on the map, which can also be used for any refinements you want to make to the optimized solution. Here you can see how it took all those stops, and in a matter of 2 minutes, built what might take a person several hours to build manually. And I doubt even a skilled router could come up with such a cost-effective route plan as our system did. What we're looking at are the results of the optimizer showing all the routes that were produced, what stops are on those routes, as well as the associated cost, distance duration, driving and serving time. I'm now going to go back to the P&D planning screen to see that all the stops have moved to the routes that the optimizer selected. As you can see, no route was overloaded. The system respected all of the attributes of the routes. For example, if liftgates were required on the stop, then they were only added to the routes that can service liftgates. The same applied to straight truck deliveries. Here on Fax Maps you can visualize how well the optimizer did. If you're happy with it, then you're ready to get the vehicles loaded and on the road. In conclusion, today we looked at 3 very powerful and efficient methods to auto-route your P&D routes. I trust you agree that they vastly improve the manual methodology that most LTL companies have in place today. Not only will our application reduce service failures, you can look forward to faster loading and lower handling costs. There is definitely a financial advantage to be realized by advancing your technology. So whether you're looking to replace your entire transportation management system, or simply want to explore engaging CLI to implement our optimization and routing solution, reach out to us. We're more than happy to discuss your future growth. Thanks for watching.